Quantum Applications to Nuclear Fusion and Fission by Jairam Ganesh. What is nuclear fusion and fission? Fission fission is where you split a uranium 235 atom or or a plutonium atom to actually two smaller and lighter atoms. So actually in that process the matter will actually decrease, so where so where the matter will actually turn into energy. Same for fusion, but but instead we're so we're actually two actually different forms of hydrogen actually combine together and also fuse to form a helium atom. So they actually use deuterium and also and also tritium to basically combine and it'll basically turn to helium. So that'll actually also lose mass, which will also give off humongous amounts of energy. So actually, fun fact that fusion is actually way more efficient than fission. It's actually three times more efficient. But also fission is also efficient, where it's also actually it's 1,000 times efficient than any other um and energy source. But the problem with fission is that it'll basically create nuclear waste. But fusion so it so it actually it like it like so it's actually still being developed. So it's actually in the experimental stage. So it's very kind of so it'll probably become a reality probably the next 5 to 10 years probably. So these processes are mainly used to create energy. So so this is the this is like a usual present day nuclear power plant which actually uses nuclear fission. So this actually this mist is just water vapor. This white smoke is just water vapor. And also this creates nuclear fission. So it actually produces energy, but it also but it also creates nuclear waste, which is highly radioactive. So this is the water outside of it. So the water actually kind of like so it kind of prevents the reactions from affecting the outside. So the water is like a safety thing. So and also basically inside this tube whose container is so where's the reaction actually happens. So this is so it's like a huge drawing of the such a drawing of the Lawrence Livermore National Laboratory. So where so they actually performed the first fusion experiment that actually created more energy than it consumed. So um so this is the inside of it. So we're actually using lasers in the inside it. So it's kind of how it probably looked like inside of the um in in sorry inside of where they performed the experiment. So how can quantum computing help with developing nuclear technologies so kind of nuclear so basically nuclear power plants kind of help with making them more efficient. So basically, quantum computers can simulate fusion and fission reactions, which can find the best parameters to use in creating energy using fusion or fission. This is important because using this data, scientists and engineers can improve the efficiency of nuclear fusion and fission and contribute to a greener future using nuclear energy. So what are some useful quantum computing algorithms that can be used for developing nuclear technologies. So some of them include kite, which is quantum imaginary time evolutions, Q Q Q Lanchas, VQE, which is also known as variational quantum eigensolver, QAOA, which aka quantum approximate optimization algorithm. The, these important algorithms can achieve quantum supremacy over classical computation in the future. So also, by the way, most of these algorithms can actually help with like simulating the reaction. Some of them can also like solve op 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 optimization algorithms like QAOA and also also Q Lanchas. So so why should quantum computing be used over classical computing in terms of nuclear energy? Here are some of the top reasons why quantum computing could be better than classical computing in terms of simulating nuclear fusion and fission. So it can simulate and solve problems more accurately than classical computers. It can also solve more like it can also solve optimization problems more efficiently than classical computers, and it can also simulate and so it also solve problems with more speed than classical computers. So does the current work being done on this important application of quantum computing. So there's not much research or any type of work being done in the nuclear energy application of quantum computation. But some laboratories and universities are doing work in this application of quantum computation. Here are some examples. One is Oak Ridge National Laboratory. Secondly is Lawrence Livermore National Laboratory, and also the University of Maryland. So, so now it's Oak Ridge National Laboratory. Researchers and scientists at the Oak Ridge National Laboratory successfully simulated a deuteron. So with a Rigetti 19-qubit quantum computer. A deuteron is a type of nuclear particle that contains one proton and one neutron, which is commonly found in deuterium. So there's also like known as heavy hydrogen, which is also usually used in nuclear fusion. Uh, so these simulations can make scientists and engineers better understand nuclear fusion and fission to improve the efficiency of the process. They also use variational quantum eigensolver al, algorithm to complete this task. Now, secondly, it's the Lawrence Livermore National Laboratory. In 2021, the United States Department of Energy awarded a $3.1 million contract to Rigetti Quantum Computing to work with Lawrence Livermore National Laboratory for simulation of nuclear fusion using quantum computation. This contract may have led to the milestone in nuclear fusion on December of 2022. This means that quantum computing may have a huge positive impact on the efficiency of nuclear fusion and fission. Third is University of Maryland. Professors at UMD, also known as University of Maryland, and and researchers from the JQI Joint Quantum Institute are doing research on how quantum computation can help with nuclear physics. They use trapped ion quantum simulators to develop accurate simulations of nuclear models that can be used in nuclear fusion and fission applications. They also do research in QCD, also known as quantum chromodynamics, which talks about the interactions between elementary particles. And this can also be used in nuclear fusion and fission applications. Uh, as you can see, quantum computation can be very, very useful in improving the efficiency of nuclear fusion and fission. Here are some of my references. So these are some of my websites where I got my images from, and there's actually more. So these are my this is my second, third page, and also this is where I got my research from. These are all the websites. First, this is the first page, and also the second page, and also this is the third page of my references, of my research references. And that's it. So thank you for watching this video. So thank you for your time, and also have a nice day. Goodbye.